If you want to follow along, I recommend this dbfiddle website. It's a free website and you don't even need to create an account. When you open the website, just click on SQL Server, that's the flavor of SQL that we're using for these videos, and make sure you choose AdventureWorks as the database. That will give you access to all of the same sample data that I'm using in these videos.
It's time to talk about window functions in SQL. Now, window functions are quite widely regarded as advanced concept, but actually coming from an Excel background, a lot of what the window functions are doing is really intuitive. It's already stuff that we've been doing in Excel for a long time. So actually, it should be fairly straightforward for us to wrap our head around these window functions. Now, just like with the aggregate functions, remember we had some aggregation functions like sum and count and average and whatever else. And then we also had the group by clause. Window functions are a little bit similar. There are some specific window functions that we can use. I'll go through those in a second. And there's also a specific special word that we need to use called over. We'll see that window functions are quite similar to group by in some ways, but there's also other ways in which they're quite different. But window functions in general, it's just another way of summarizing data. That's the best way to think about it. It's summarizing data, but without reducing the number of rows. The group by summarize data by reducing the rows. The window functions are going to summarize data without reducing the rows. So let's jump into it. Let's see this. To kick us off, let me actually point out some of the functions that we can use in a window, or some of the functions that we can consider window functions. The aggregate functions that we've been using so far, like count, average, sum, min, max, we can use those in a window. We can use them as window functions. We'll see an example of this shortly. But there are other specific functions that are specifically for using in a window. There are these ranking functions, and there's also these analytic functions. We'll go through lag as the example of these. So I'm bringing this up because there's quite a lot of different functions that you can use. We're just going to use a couple of them just to illustrate some concepts. But after this video, I strongly recommend you check out the rest of them that we haven't covered, just so you can see what's available. Let's start with an aggregate function that we're familiar with. We'll start with the count function. So we've got our usual human resources table, the department table that we've been using so far. If we had just done count star, do you remember what this does? Just summarizes the rows and tells us how many there are. We've used count star, so this is specifically counting the number of rows. So we're going to get 16, because that's how many rows are in the department table. When we use window functions, or when we use functions over a window, we're still going to be doing aggregation, similar to this, but we're not going to be reducing the number of rows. Let's see an example of this and then we'll pull it apart. What I'm going to do is I'm going to add in the department ID and the name. And usually you can see my SQL software is starting to complain because this isn't valid SQL. I'm asking for an aggregate, but I'm also asking for the specific columns. Of course, in other examples, we fixed this by adding them to the group by, but this time, what we're going to do is we're going to say to SQL, we're going to say to the database that we want to do this count without reducing the number of rows. And the way that we specify that is by writing the over special word. It always needs to be followed by brackets, and sometimes we'll stick things in these brackets. We're going to see that later on. But just to start off, we'll start off with an empty pair of brackets. And these brackets are required even if they're empty. So this looks a bit funky. What's this going to do? Well, let's run it and see if we can spot what's happened. Can you see what's happened here? The count, when we summarized the table, was 16. Now we've added that same count to the table without reducing the number of rows. And we can do the same with any of the other aggregate functions as well. Just so that it's aligned to the left, let's order by the department ID. Let's do one other aggregate function. Let's do the sum of the department ID. Without the over, this would be treated like an aggregate function, which is why my program's complaining. In order to tell SQL that we want to do this aggregation without reducing the number of rows, we add in the over special word at the end with no brackets. Sorry, with empty brackets. Let's run this again to see what we get. This time, we're getting 136. Remember, the sum of all of these is indeed 136. So we've done the aggregation without reducing the number of rows. This is super convenient. Now, the reason that these brackets are empty is because inside these brackets, we can specify things like group by. We can specify the groups that we want to do these counts over. So by doing empty brackets, we're saying count over the entire table. Sum the department ID over the entire table, which is why it's done exactly that, the entire table. So let's see some other examples. Let's actually do some grouping over some columns. We'll do some aggregation, some window function aggregation over some columns. So just to keep our output nice and easy to see, I'm going to get rid of name, but we're going to use group name instead. And for now, let's just stick to the count function. So I'm just going to rerun this before we jump into it. So this is what our output looks like. Inside the bracket after over, we can specify two things. We're only going to use one of them for right now, but I'll show you both of them, and we'll use the second part later on. We can specify a partition, and we can specify an order. So the order, just like the order by clause that we're familiar with, but we'll see how this is useful later. We'll ignore it for now. The partition is just the same as group by. It's just the words that we have to use are partition by when it's inside the overs brackets. But you can think of this as being identical to group by without reducing the rows. That is, we're inside a window or we're using the over clause, so we're not reducing the rows. But partition by, you can think of it as doing the same thing as group by. Let's prove this. Well, if we were to partition by the group name, well, now we're counting the number of rows per group name. Let's run this and see what we get. Since this is quite small, let me just whack this up. Let's see what we've got. So research and development, that's got 3. And that's because there are 3 research and development rows. Sales and marketing have got 2, because there are 2 sales and marketing rows. Inventory management is a 2, because there's 2 inventory management rows as well, etc. If we were done just to compare this to the group by version, let's just quickly do a group by. And we'll just do this. If we'd done the group by on the department name, we're getting the same counts. So research and development is 3. That's why we've got the 3s here. But we're just not reducing the rows. We're not reducing the number of rows that we have if we're using the over clause. Sales and marketing is 2. Sales and marketing is 2. Inventory management is 2. Inventory management is 2. Executive general and administration is 5. So the numbers that we're getting in the window when we're using the over special word are the same ones that we would get if we were using the group by. That's why these are so similar. If you know group bys, you know window functions when we use them in this way, because it's doing exactly the same thing, but it's just not reducing the number of rows that we have. You may be thinking, well, this is just like the COUNTIF function. And you'd be absolutely right. Let's just whack it in just to prove it. We'll color it orange to remind us that it's not usually in here. What we've done here is exactly the same as doing COUNTIF in this way. COUNTIF, count the entire group name for the current row. You see, COUNTIF for research and development, there's 3 of them. Because there's 3 rows that are research and development. Sales and marketing, there's 2 of them. There's 2 rows that are sales and marketing. So what we've done here with the count over partition by group name, it's just COUNTIF on the group name. So if you've seen this in Excel, the transition should be super straightforward. It's just a COUNTIF. Now this is a bit of a silly example. So let's move on to a much better example where we'll see how we can do things that are very familiar to us in Excel in SQL for some aggregated sales data. For this example, let's use these aggregates. So this is the sales file. This is a pivot table on the sales order header table. And what I've done is I've summarized the total due. I've summed the total due by the year and the quarter of the order date. Now, at the time of recording, I'm on Excel Web, and Excel Web doesn't have the option to group dates in a pivot table. So I've had to explicitly add order year and order quarter to this table in order to do this summaries. But if you're on the desktop version of Excel, you should just be able to piggyback straight off of the order date column to get an output similar to this. But tangent aside, first things first, let's try and recreate this summary in SQL. So what we're going to need to do, we're first going to need to open the sales order header table. So as always, we start with selecting from, we're in sales and it's sales order header. Let's run this to make sure that we can open it. We sure can. So the first thing that we're going to need to do is get the year and quarter. We've seen that we can get the year just by using the year function. So we'll do this as order year. And to get the quarter, we're going to use something that we haven't explicitly shown in these videos yet. It's date part. We want to take the quarter from the order date. I'll call this order quarter. And finally, we want the total due. So I've updated my code. Let me run it just to make sure that this works. Sure does. Just to confirm that this is indeed doing what it's supposed to be doing. Let's also get an order date. So May is indeed quarter 2. So I'm happy that the date part function is doing what it's supposed to be doing. So this is the individual sales. We now need to summarize them. In particular, we want to sum the total due. We'll call that sum total due. And we want to group by the first 2 columns. Remember, we can't just write order year and order quarter. We have to redo or rewrite the calculations that we've used in order to get those 2 columns. So here we go. And for good measure, let's just do an order by so that we can compare it nicely. There we go. We now have the same information as on the left, and this is going to form the basis of our upcoming example. Now, to make this example even easier for me to write, what I'm going to do is I'm going to save this into a subquery. So let's do with, I'm just going to call it aggregated sales. I'm going to pop all of this into it. I'm not going to do the order by because we're going to do the order by right at the end. So what I can do is I can now select everything from aggregated sales, ordering by order year and order quarter. So I'm just going to rerun this to prove that it's the same output. It sure is. So we've got the same thing. Now let's actually do some additional manipulation on top of this aggregation. We're going to add 3 columns to this pivot table. We're going to add a quarter on quarter difference. How much has the current quarter increased compared to the previous quarter? We're going to add a yearly running total. And we're also going to add a 4-quarter moving average. If these words don't mean anything to you yet, we'll define them in Excel first, and then we'll move over to SQL anyway. So you'll have an opportunity to learn what these are. And also, just to make the right-hand side a little easier for me to see, my program allows me to collapse certain bits of the query. So I'm just going to collapse the CTE, the aggregated sales CTE. So that means that it's just hidden. When it runs, it's still running that part of the query, but it's just hidden. So it's going to be easier for us to use this output. Let's also whack those on the same line. Let's start with the quarter-on-quarter difference first. This is the difference between the current quarter's sum of total due and the previous quarter's sum of total due. So in Excel, this is really simple. I will note for the first line, we don't have a previous quarter's sum of total due, so we'll just leave that blank. So starting on the second row, all we're going to do is we're going to take the current row's total due minus the previous row's total due. Easy peasy. Same column, just one previous row. And we'll fill that down. Here we are. Easy peasy. And that's one of the things that I love about Excel. So easy to do things like this. We can do the same thing with SQL. There's a specific window function that we use for going one row back, and that is the lag function. And in the lag function, we need to specify which column we want to go back on. We want to go back on the sum total due. This is the one, this is the column whose row we want to grab one behind from. Now, with every window function, we always need to specify over with some brackets. And in the case of lag, SQL doesn't know what order the rows are in. I know that we specified one on the outside, but SQL's not going to assume that when we do a window function, we want the same border as on the outside. That might feel a little bit annoying, but actually that has a lot of benefits, which we're not going to go into right now. But since the order of the rows is the order that we want to use for the lag, we're just going to copy the same order into here. Now let's see what this gives us, first of all. We can see that we are indeed, for every row, getting the previous row's value. So in order to then calculate the quarter-on-quarter difference, we're just taking the current row's sum total due minus the previous row's sum total due. So let's see what we get here. Now we're getting exactly the same thing. We even get the null at the start as well, same as in Excel. So this lag, sum total due over order by, order year, order quarter, sounds complicated, but this is just the previous sum total due value. That's all it is, easy peasy. So let's call this the quarter-on-quarter diff. And let me just give myself a bit more space, we'll do that. So we can keep this visible. So that's the first one done. We use the lag function to go back a row. We just need to make sure that we specify the order. But we've done exactly the same thing in SQL as we've done with Excel. Next up, let's do the yearly running total, and we'll give ourselves a bit more space. We're going to hide this column so we can get a bit more space, and we'll also hide this one too, so we can get a bit more space in the output. We know that the quarter-on-quarter difference is correct, so we'll ignore it for now. To get the yearly running total, well, what does that mean? That means that we want the running total, which is the sum of total due, the cumulative sum, the running total, but we want it per year. So what does that mean? I'll do it manually first, and then we'll write the Excel function that does this for us. So the yearly running total, starting here, is just going to be this value. In this month, well, it's going to be this one, and it's going to be this one. In this quarter, it's going to be this one, and this one, and this one. Then in 2012, we start again. It's a new year, so it's just going to be this one. Then it's going to be this one, plus this one, and so on. I hope you can see where I'm going with this. So every year it resets, but within the year, it continues to sum up. So this is the way I've done it manually. How would we do this with Excel? We'd use the SUMIFS function, SUMIFS. Or SUMIF. We only need one if condition. So we want to check the current year. Now what I'm going to do, I'm going to set this up this way. We're going to need the range that we're summing over to change over time. Change per row. So let me whack these in first, and then I'll explain what we've got going on. I'm just going to copy this down, Here we go. So let's actually see what this is doing. It's not super easy to see on the first line, so let's go on to the second line. This is saying, look at everything so far in the year and check whether it's the same as the current year. And also look at the sum of all of the, and look at all the sum of total dues so far. Since both of these are 2011, which is the row that we're looking for, we're going to sum both of these. As soon as we go to 2012, we're looking at everything up until that row. We're also looking at all the sum of total dues up until that row, but we're only going to keep the rows that are 2012. So we're going to forget these 2011 ones and only get this value. Similarly, at the end of 2012, we're looking at everything up to 2012. We're only going to keep the rows that are equal to 2012, which are these four. So this value is just going to be the sum of these four values. Let's confirm it. If I highlight that, it certainly is. If you've not come across yearly running totals before, they're quite a helpful metric, quite a helpful statistic that people like to, particularly management, that management like to track. So it's a good one to try and wrap your head around. It's a good one in your own job. Think, how can you apply a yearly running total in some of the stuff that you're working on? But if you are familiar with this, great. This should be simple stuff for you. So this is what we've done in Excel. This is what we call a cumulative window. Every time we go to a new row, we're getting all of the rows previously. Yeah, it's a cumulative sum. It's a running total, so it's a cumulative window. We can do exactly the same thing with SQL. So all we want to do this time, we just want a sum, and we're doing a sum of sum total due. I know 2 sums in a row is what it is. So we're doing sum of sum total due. We know we don't want to be reducing the rows. So we know that we want to add over. And every time we write over, we need to write the brackets. But how are we going to get this to emulate this behavior? Well, let's see what happens when we just run this. If we just run this, we saw this earlier. If we just run this, then we're summing everything. This is the sum of all of this. So what we want to do is we want it to reset. Well, there's 2 things that we want to do. Let's do them individually. First of all, we want this to reset per year. And the way that we can get this to reset, we use the partition. We want to partition by the order year. So change for each year. Let's give this a run to see what the output is like now. Here we go. So now we're not getting the running total, but we are getting the total for that year. Let's just confirm. So what's the total for 2011? If I sum the 3 of these, yeah, that's the same thing. So how are we going to tell SQL that we need this to be this cumulative window? We need it to be just look at the previous rows, not all of the rows. Well, we just add in order by. We whack in order by. Since we're partitioning by the order year, we don't also need to order by the order year, so we'll get rid of that. If we order by the order quarter, then by default, SQL is going to realize that we only care about the rows up until that current row based on order quarter. So if I give this a run, we're now getting exactly the same information. We're getting the same running totals, because when we do the order by, when we're on this particular row, we're saying to SQL, sum the sum total due, so sum all of these, but only where the year is the same, and do it in this order. So when we're halfway through 2012, let's say we're on this line, because we're using the partition, we're saying only focus on this block. And then on line 3, with the order by, we're saying we'll only focus on the 3 up until this point, which is why we get the running totals. Now, a lot of people don't know that you can use sum with the over, the partition by, the order by in this way, or just the sum with the order by to do a running total. But this is such a convenient way to do running totals in Excel. Again, it feels a little bit weird. Even the Excel formula feels a little bit weird if you've not seen it before. So I appreciate this feels a bit weird, but really all we're doing is we're saying sum the total due, reset each year, and give me a running total by ordering by the order quarter. And so we've got exactly the same thing as on the left. Using sums in this way, I can't stress enough, it's such a fantastic way to use window functions. Now let's move on to the last example, the 4-quarter moving average. So I'm going to hide the yearly running total to give us a bit more space. And I'll hide this one as well. I also forgot to give this a name, so we'll call this yearly running total. We'll hide this as well, just so that it doesn't clutter up the output. How are we going to do the 4-quarter moving average? Well, a moving average, in this case a 4-quarter moving average, that just means that take the average of the previous 4 rows, or the previous 3 and the current row, however you want to think about it. So setting this up in Excel, the first few rows are a bit slow, but then it's very easy. So for the first ones, for the first row, we're just taking the average of the first row, which is the first row. For the second row, we want the average of the previous 2. Oh, you can tell I do SQL more than I do Excel now. Average. Then next one, we want for the third row, we want the average of the previous 3, and then for the fourth one, we want the average of the previous 4. And this is the one that we can then just drag down to reuse. So I'm going to drag this down. Here we go. And this is a moving average because every time we move down a row, that range moves with us. This is what we call a sliding window, because the window, the range, it slides with the row, sliding down with it. Easy peasy. This is another statistic, another metric that management like to keep track of. So this is a good one for you to know about as well. But how can we do this with SQL? Well, we want an average. So let's start with average, AVG. And we know we want the average of the sum total due. We know that we're not reducing the number of rows. We know we want to keep the number of rows the same. So we want to whack in over, and we always need the brackets in over. Let's just remind ourselves what this would give us straight away. So at the moment, this is the average of everything. So if I do this one, see it's the average of everything. But we want to set it up to be a sliding window. Now we don't want to use a partition this time. We don't want the average to reset each year or reset each quarter or anything like that. So we're not going to use partition, but we are going to use order by. So let's try this out. Let's whack in the order by. And like the lag, we're going by the year and quarter. The sum was special. We didn't need to specify the order year in the order by because we'd already specified it in the partition. But for the average, we want to make sure to make sure that these are in the right order. It's always the year first and then the quarter. So let's run this to see what this gives us. Well, the first few are correct, but then the rest of it aren't. And this is because it's doing the same thing that the sum did. It's doing a cumulative window at the moment. It's taking the average of all of the previous rows. So that's why the first 4 are equivalent, but the 5th one is the average of all of the previous 5. And that's not what we want. We want this to only be the previous 3 rows and the current row. So there's a special word. When we're using an order by inside the over special words brackets, the overs brackets, there's a special set of words that we can add after the order by to control the rows that we're looking at. And that is rows. In this case, we want 3 preceding. Rows 3 preceding means the previous 3 rows and the current row. This is the shorthand for it. There is a slightly longer way that you could write this. You could write rows between 3 preceding and current row. But that's a lot more to write. So for right now, we're going to stick to 3 preceding. Now let me run this to see what we get. Now we're getting exactly the same outputs. we've implemented a sliding window because we're saying for every row, I just want the previous 3. It's relative. As the rows move down, the window moves with it. So this is how we can get exactly the same as what we have in Excel. This is another one that people don't really know well in SQL, but it's so easy to implement. Once you wrap your head around how the window functions are working, it's so easy for us to do a moving average in SQL. Let's put the 3 of these together. So we'll unhide these rows. We'll zoom out a smidge so we can see it all. And similarly, we'll unhide these so we can see all of these in their glory together as well. We do indeed. Oh, and let's give this one a name. So this is the 4-quarter moving average. So we can't start it with a number. 4-quarter. So we have indeed done exactly the same things in SQL as we did in Excel. So really, these window functions, we're already familiar with how they work, or at least the over clause, or using aggregate functions as if they were window functions. Because it's just like doing sliding ranges in Excel, or relative lookups in Excel. We're already familiar with how to do this, and a window function is just giving us that flexibility. So to wrap up, we've seen that there are lots of different types of window functions, but they all hinge on this over special word. When we use this word, we're telling SQL that we want to summarize some rows without reducing the number of rows that we currently have. When we use the over clause, the over special word, we always have to have brackets after it. And we can optionally choose some partition. Remember, this is just group by, but for whatever reason, we've got to write partition instead of group by. And we can write order by, so that the function, the window function that's doing some aggregation, can do things over some window. And we saw that the windows are really flexible. If we don't specify an order by, it's just going to run that function on the entire window. If we do specify an order by, then by default it's going to be a cumulative window, everything from the beginning up to the current row. And if we want a sliding window, we can specify the range of rows that we want to consider in the window function. So window functions, they're really familiar to us because we already do this kind of stuff in Excel. But it's such a fantastic way to improve your SQL queries, to be able to add even more good quality metrics to your SQL results. But that wraps up window functions. I hope you found this useful, and we'll catch you in the next one.